Let's take a look at this chapter. This is first section of 3.1, Quadratic Functions and Applications. And it talks about vertex form. So quadratic functions, vertex form. This is also known as standard form. And we got f of x is equal to a times x minus h squared plus k. If a is greater than 0, then your graph opens up. If a is less than 0, your graph opens down. Vertex is h comma k. Your axis symmetry, I'll label as AOS, is x equals h. And your min, you have a min if your a is greater than 0, or max, you don't have both in these problems. Your max is if a is less than 0, is equal to k. So if I have a problem, f of x is equal to 3 times x minus 2 squared plus 1. Let's find all the different pieces. First off, let's identify our a, h, and k. A is whatever number's in front of your parentheses, so a is 3. Now if there isn't a number here, remember there's an invisible 1 there, so that a is equal to 1. This is our h, and it's always going to be opposite sign. So h is going to equal to positive 2. And this is going to be our k, and this is k is equal to 1. Now a is positive, so I know it's going to open up. Graph's going to look like that. Even more than that, coming down here to the min or max, since a is positive, we know we're going to have a min. Now the reason why we have a min is since it is opening up, we do have a lowest point, but we don't have a highest point because it keeps going up forever. Now our vertex. Our vertex is going to be hk, which will be 2, 1. So that's our vertex. We know it's going to open up, and these quadratics have a U shape to them, so you keep that in mind, a parabola. Now our axis symmetry, we said was x equals h. Well, we said h was 2, so we got x equal to 2. That means there's going to be an invisible line here at x equals 2. And we'll talk more about that here in a second. Now we already said we have a min, and our min's equal to k, and k was 1. So our min is 1. Now you really need one other point, I should say. Once you got 2 points, your vertex and the other point, that's really all you need to kind of get the look of the graph. Now you want to pick a point that's 2 units away. Now we're currently at x equals 2 here, so I could come here to x equals 0, or I could even come here to x is equal to 4. Either one of those would be appropriate. I'll pick x equals 0. Now I'm going to plug that into the function. Remember f of x is y. So we've got y is equal to 3 times 0 minus 2 squared plus 1. Negative 2 squared is 4 times 3 is 12 plus 1 is 13. And that went up pretty fast. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's right there. And we know our graph's got kind of a U shape to it, so it passes through this point, Let's try that again. Not that I can draw them real well anyway. And then this side will be symmetric. Let's see. There we go. Finally. Halfway decent. Not great. And then this side's symmetric to the line x equals 2, the axis of symmetry, which means after you get your left side, you can flip it over and you get your right side. So that's what the vertex and axis of symmetry is used for. In some problems, they may ask you to find the minimum or maximum of something that's quadratic. Whenever they say find a minimum or maximum, they're saying find the y part of the vertex, and that's your min or max. Okay, let me talk about the general form now. Our general form for a quadratic looks like this. Got f of x is equal to ax squared plus bx plus c. And if a is greater than 0, then your graph's going to open up. If a is less than 0, your graph is going to open down. Your vertex is negative b over 2a, f of negative b over 2a. Your axis symmetry, label as AOS, is x equals negative b over 2a. And your min, and you have a min if your graph opens up, if a is greater than 0, or your max is when your graph opens down, is going to equal to f of negative b over 2a. Okay. So if I have f of x is equal to negative x squared plus 2x plus 1. First off, let's identify our a, b, and c. Now a is going to be whatever's in front of our x squared, which is negative 1. B is going to be whatever's in front of our x, which is 2. And c is our number at the end, which is 1. Now I know a is negative. It's less than 0, which means it opens down. Even more than that, from my instructions, that means we have a max, because we have a highest point. Now we don't have a lowest point because it keeps going down forever, but we do have a max. Okay. Now the first thing we'll take a look at is the vertex. And this has actually got a name. It's called the Vertex Formula. And step 1 is to identify a and b. Step 2, plug a and b into negative b over 2a and simplify. Step 3, plug the value from step 3, step 2, into the original function and simplify. Now on step 2, once we find that value, that's the x part of the vertex. And for step 3, this is the y part of the vertex. So step 1's easy. We've already identified a and b. A is negative 1 and b is 2. Step 2, we want to plug those values into negative b over 2a and simplify. So we're going to have negative 2 over 2 times a, which is negative 1. That gives us negative 2 over negative 2, which gives us a positive 1. And this is the x part of the vertex. Step 3. We want to plug that value back into our original function and simplify. So we're going to have negative 1 squared plus 2 times 1 plus 1. So I'm just plugging that x value back up here. So that's negative 1 plus 2 plus 1, which gives us 2. And this is the y part of the vertex. So our vertex is going to be 1, 2. Our axis symmetry will be, notice our formula for the axis symmetry. X is equal to negative b over 2a. Well, this right here happens to be the x part of the vertex. So if you have the x part of the vertex, you have your axis symmetry. So this will be x is equal to 1, the x part of the vertex. Now we've already said we're going to have a max. And look what our max is equal to. F of negative b over 2a. Well, that happens to match this right here, f of negative b over 2a. So the min or max is equal to the y part of your vertex. So our max is going to equal to 2. Now I already showed you how to graph one of these by hand. Let me show it on the calculator this time. I need to set my calculator up because I've been doing some other things with it today. Okay. Now I'm going to go to my y equals, press clear to clear out wherever's in that line. And then I'll do negative, which is on the very bottom row, x key, and then the x squared, plus 2x, plus 1. And then I'll press graph. And that's what our graph would look like. Real quickly, the create quadratic models using regression. Let me talk about that. Let's say I have some points. I have the point negative 2, negative 1, 0, 1, 2. And this is, let's say, I don't know, 5, 12, 31, 7, and 1. Got these points. Well, I'm plugging in my calculator. Where you put those points in at, you do second mode exit out of anything in the calculator. You push your stat button right here, and you see we're under the edit, and you just simply press enter on edit. If you have numbers here, you can just simply press delete over and over to clean those numbers out. Don't press delete while you got L1 or L2 highlighted though. That'll delete the list. And then I'll put in negative 2, negative 1, 0, 1, 2. And I'll put my y values in L2. So I got 5, 12, 31, 7, and 1. Exit out, do second mode. Now I'm going to set my diagnostics. So I'm going to do my second button here, and then I'll choose this 0 to go into the catalog. And then I'll push this button, looks like x and negative 1. That's not x and negative 1, that's actually the inverse button. And we'll go down the D's automatically. Or if you just get into the catalog, you keep pressing down arrow over and over, you'll eventually find diagnostic on. And you press enter on it twice. Now come back and say done. Now if I do stat, you only have to do that diagnostics on one time. Then I go to calc. Then you see there's one that says Quadratic Regression number 5. If I choose it and then press enter, that'll come back and give us a model. You see the y is equal to ax squared plus bx plus c at the top? And then I'm going to plug in my a, b, and c I found. I'll take them to 3 decimal places, I guess. So y is equal to negative 4.929 x squared and minus 1.3 x plus 21.057. And this would be our model. Now it's the quadratic that best goes through these points. Nothing will go through it perfect unless I've designed it to go through perfectly. So that's why you have decimals. There's error. The r squared you see right here tells you how good of a model it is. The closer it is to positive 1, the better the model is. This isn't a great model of what I've came up with. That's 0.65. I actually meant for it to be a little bit better the way I designed the numbers, but the r squared again tells you how good it is. Okay. So let's go on to section 3.2, Introduction to Polynomial Functions. Grab a drink here. First off, let's talk a little bit about polynomials. We have a term, which is a number times a variable. And I put an S on here to indicate you can have more than one variable. An example of this would be like 3x squared. That's 3 times x times x. You got variables. When I say variables, I'm talking about multiplication in between them. Or a variable times a variable. And again, I'll put an S on here to indicate you can have more than one. We have a monomial, which is one term. We have a binomial, which is two terms. We have a trinomial, which is three terms. And what we're studying in this section, a polynomial, which is one or more terms. We have something called standard form. This is when your terms are arranged from largest power down to the smallest power. Now we have something called degree, which is your largest power of x. It's actually a little bit more than that, but for purposes of this class, that's going to be the best definition for you to work problems. Now, in general, polynomials cannot have negative powers, they cannot have fractional powers, or variables in the denominator. Graph-wise, polynomials cannot have sharp corners, they cannot have gaps or holes. Now in terms of that negative powers, fractional powers, variables in the denominator, there's actually a lot larger list of what a polynomial cannot have. I believe I could write an infinite list of all the different things it can't have. Can't have a square root, can't have a cube root, can't have a fourth root, on forever. But these are the three most popular ones you see in algebra books. And they'll just give you something, they'll ask if it's a polynomial. And if you have any of those, it's not. Now we have, see how they're talking about determine the end behavior? This is based upon a leading term. The leading term is the first term of the polynomial when it is in standard form. We also have the leading coefficient. This is the coefficient of the leading term. Coefficient's a number in front of the x to whatever power. Now I'm going to refer to this as coefficient. Realize the coefficient is kind of a general, but that's how I'm going to label it. Then we got leading coefficient test. And the different possibilities, we could have an even degree, we can have an odd degree, so those are your two possibilities for the degree. We could have a positive coefficient, or we could have a negative coefficient. Now if you got a positive coefficient and you got an even degree, it's up to the left, up to the right. If you got a positive coefficient and odd degree, it's down to the left, up to the right. Let me start down a new page. Now if you got a negative coefficient and you got an even degree, it's down to the left, down to the right. If you got an odd degree and negative coefficient, it's up to the left, down to the right. Now this tells you what is your graph doing as it goes clear to the left, goes clear to the right. Let me show you an example. If I got f of x is equal to negative 3x to the fourth minus 7x plus 3. And we want to determine the end behavior. Well, we're going to look at our first term, that's your leading term, and we're going to look at its coefficient. The coefficient is negative 3. So the coefficient is negative. And we'll look at the power. This is an even power. That's our degree also, since it's our first term in standard form. So we're going to look up coefficients negative, even degree. Even degree is right here. Negative coefficient, where they intersect, will be your answer. So it's down to the left, down to the right. So down to the left, down to the right. I don't know much more about this graph, but I do know as it goes clear to the left, it's going to go down. As it goes clear to the right, it'll go down. It can be doing anything else in the middle here. I have no clue about it. All this test tells us what's it doing as it goes clear to the left and goes clear to the right. We're going to see that in a little bit more detail here in a minute. Now, next problems ask, or next topic is asking us about the zeros and multiplicity. And I'm going to combine this with sketching and then connecting that with the leading coefficient test. I'm not going to go over the intermediate value theorem. You can read about that yourself. It's just a limited amount of time. Okay. So let's take a look at this problem. Okay, so we have f of x is equal to x to the third plus 5x squared plus 3x minus 9. I think, let me double check that. 6x plus 9, x to the third plus 6x squared plus 9x minus x squared minus 6x minus 9. That gives us 5x squared. 9 minus 6x is 3x minus 9. Well, that doesn't really factor, but bad example. Let me leave it in factored form. Okay, so we say we have something looks like this, and I want to find the zeros. I want to find the multiplicities. I want to talk about the end behavior again, and then I want to bring it all together to sketch. Well, to find the zeros, how you always find the zeros is you're going to set whatever you're working with equal to 0. So I'm going to set that equal to 0. And normally you would factor this. This doesn't factor, that's why I couldn't use it direct. But it factors this way. Then I set each factor equal to 0. So I got x minus 1 equal to 0 and x plus 3 equal to 0. And so we get x is equal to 1 and x is equal to negative 3. Now these are zeros. That's where it's crossing the x-axis. So here's negative 3 and here's positive 1. Now let's talk about our multiplicity. Multiplicity refers to how many of them do you have. And always go back to the power you have on this. This x plus 3 had the second power on it, so its multiplicity would be 2. Now if I were to put a power on this other one, it would be the first power. So that has multiplicity of 1. Now what that tells us is whether it touches or crosses. If you got an even multiplicity, that means it touches. So this touches. If you got an odd multiplicity, it means it crosses. This 1, it crosses. So over here at 1, I know it crosses, and over here I know it touches. Now if we look at our leading coefficient test, and it really does work out best if you got to multiply it out for the leading coefficient test. There is a way to do it just by looking at this. It has to do with taking your x to the largest power to whatever power you have here. So x to the second power is x squared, and then you do the same thing over here. This is x to the first. And x squared times x gives us x to the third. But if we take a look at our leading coefficient, this has got a positive coefficient, and it's got an odd degree. So positive coefficient and odd degree. Positive coefficient, odd degree would be this right here. It says down the left, up to the right. So I know it's going down the left, and I know it's going up to the right. Touches here and crosses here. So our graph is coming up, and we know it touches here, which means it'll touch at a point and come back down. Then at some point it has to turn around, because it has to come up here to cross. And I know it's going down the left, so that's why I know it's going like this, and it's going up to the right, so that's why I know it's going like that. Versus coming down and touching a point here, coming up, and then turning around. Now this gives us a rough idea of what our polynomial sketch looks like. You could then plot points, like I could plug in x equals negative 1. And that would tell me maybe how far down does this go, because I'm just guessing on where it actually came down to. I could maybe plot some more points over here, maybe at 2, or maybe at negative 4. And those 3 points there, if I build a t-chart, will give me a pretty good idea of what's happening with the graph. So the zeros, multiplicity, touching and crossing, and leading coefficient test gives us the general framework of what it looks like, and then we can go from there. We're going to do these on a calculator though, so we'll still need to find these, but if you're sketching this on the calculator, it's pretty straightforward. We're going to press our y equals, clear. Then I'll do my x, and how you do a power is this caret right here. 3. If you got one of the New Year T84s, you have to do a right arrow key to get out of your exponent mode. Plus 5x squared plus 3x minus 9, and then you press graph. And you can see I was right about the touching and the crossing. I was not correct on how far down it goes. Probably closer on this little red, though I was just guessing there. So this is where you need to really kind of plot a point to get an idea of exactly what it looks like. Okay, that's basically that section. So let's go on to section 3.3, divisions of polynomials, remainder, and factor theorem. Grab a drink here. Clear this off. And we'll look at polynomial division and long division. Okay, so we got x squared minus 7x plus 1. I'm just going to give you the general process here. I got a lot more examples out in YouTube videos you can go and watch to get an idea. Now we're going to look at the first term of each to decide what goes up on top. And it's always exact. It's not how close. It's always exact. So you ask yourself, what times x gives you x squared? And that'd be x. Now whatever you put up on top, you're going to multiply by what's out in front. So we're going to take x times x minus 3. X times x is x squared. X times negative 3 is negative 3x. Now we're going to subtract that line, which means flip signs. So the positive x squared becomes a negative. The negative 3x becomes a positive. Some of you will do that in your head, but I can't show you steps in my head on the board, this board very well, so I'll do it this way. X squared minus x squared drops away. Negative 7x plus 3x gives us negative 4x. And then the 1 carries down. And then we repeat the process. So we look at the first term of each side, what goes up on top. And you ask yourself, what times x gives you negative 4x? And that'd be negative 4. And again, whatever you put up on top, you multiply by what's out in front. So take negative 4 times x minus 3. And that gives us negative 4x plus 12. Now we're going to subtract that line, which means flip signs. So this becomes a positive, this becomes a negative. Negative 4x plus 4x drops away. 1 minus 12 is negative 11. Now remember, your degree is your largest power of x. So the negative 11, degree is 0. The degree of x minus 3 is 1. When the degree of this becomes less than what you're dividing by, this is always your remainder. And you take your remainder and you put over what you're dividing by. So put negative 11 over x minus 3. You could, if you wanted to, put the negative out in front. Some people put it up on top, some people put it out in front. When I say people, I'm talking about textbooks. So it's not really one set standard for that. But that was long division. Now let's take a look at synthetic division. And actually, maybe I'll use the same numbers. Got x squared minus 7x plus 1 over x minus 3. And this is synthetic division. Step 1 of synthetic division. You take what you're dividing by, you set it equal to 0 and solve it. So we've got x minus 3 equal to 0, which gives us x equals 3. We then want to take that number we just found and put in a box in the upper left-hand corner. Now we want to identify our largest power. Our largest power is an x squared, so real small I'll write x squared, x, and no x. You have one for each power going down after you find your largest one. So x squared, x at first, no x, which is our constant term. And we want to write down the number that's in front of each one of them. The number that's in front of our x squared is a 1. The number in front of our x is a negative 7. And no x, or constant term, is a 1. So I'm going to add, multiply over and over. 1 plus nothing's 1. Multiply. You always multiply by a number in a box, by a number you put down there. 3 times 1 is 3. Add. Negative 7 plus 3 is negative 4. Multiply. 3 times negative 4, you always multiply by a number in a box, by a number you put it down here. 3 times negative 4 is negative 12. And then add. 1 and negative 12 gives you a negative 11. So again, I added. 1 plus nothing. There's always nothing here to begin with, so you can just bring the 1 straight down. Then you multiply. You multiply whatever number's in the box by number you put down here. 3 times 1 is 3. You put it here. Then you add. Negative 7 plus 3 is negative 4. Then you multiply. Always multiply by number in a box by number you put down here. 3 times negative 4 is negative 12. And then add. 1 minus 12 is negative 11. Now this was x squared. This will be 1 degree lower. So this will be x. This will be no x. and this is our remainder. So we're going to have x minus 4, and we put a remainder over what we're dividing by, which was x minus 3. And you see we come up with the same value, same answer, as what we came up with here. Now I might look at that, and once synthetic division clicks with you, you'll love it. It's like kind of use it on every problem. Wish you could, but the only time you can do synthetic division is when you're dividing by x plus a number or x minus a number. If I was dividing by 3x minus 1, we could not do it because we have a number in front of the x. If I was dividing by x squared minus 2x plus 1, could not do it. The only time we can do it is when it's x plus a number or x minus a number. Now that seems kind of limiting, but we'll find in the next section, when we're talking about the fundamental theorem of algebra, it's not as limiting as it sounds because every one of the problems will be of that form. Okay, let me erase that. Now the remainder theorem. Let's see, we got f of x is equal to 2x to the third minus 7x plus 1. And we want to find f of negative 3, I guess. Remainder theorem is another way to evaluate a polynomial function. You're going to take the number you're evaluating for, whatever number's inside the parentheses here, and that goes in your box. Now we want to identify our largest power of x, which is x to the third. So real small, I'm going to have an x to the third, I'll have an x squared, x, and I'll have a no x. By putting these across the top, and make sure that everything's in standard form and you're not missing any powers. Now the number that's in front of our x to the third is 2. The number that's in front of our x squared, we don't have an x squared, so we put a 0 there to handle that. There's no number, well there's a negative 7 in front of our x, and then the no x constant term is 1. Now I'm going to add and multiply over and over, so I start with my first column. 2 plus nothing is 2. Then I'm going to multiply. You always multiply by number in the box, but number you just put down there. So we're going to take a negative 3 times 2 is negative 6. And then I want to add 0, negative 6 is negative 6. And then multiply. You always multiply by number in a box, by number you put down there. Negative 3 times negative 6 is 18. Add. Negative 7 plus 18 is 11. Multiply. Negative 3 times 11 is negative 33. And add, and we get negative 32. Now the remainder theorem says if you go through and you do synthetic division, your remainder is your answer. So that tells us that f of negative 3 is equal to negative 32. Let's see if that's true. We'll do it the old style. Take my negative 3, plug it in for x. So I got 2 times negative 3 to the third minus 7 times negative 3 plus 1. Negative 3 to the third is negative 3 times negative 3 is 9, times another negative 3 is negative 27, times 2 is negative 54. Negative 7 times 3 is 21, plus 1. That gives us negative 54 plus 22, which ends up giving us negative 32. So again, the remainder theorem is just another way to evaluate a polynomial function. Doesn't work on anything but polynomials. You can't have a rational function or absolute value function or anything like that. Let me clear that off. And let's actually I'm going to talk about the factor theorem on next part. So let's take a look at the zeros of polynomials. Now I'm first going to show this one of these by hand, and we'll talk about the factor theorem at the same time. So let's take a look at this one. we got f of x is equal to x to the third minus 3x squared. Actually, I don't want to show that one. Since I'm not going to do many by hand, let me show this one. This is a better one, because some of you will look at that and say, well, why didn't you use factoring by grouping? Plus 16x minus 3. This is kind of a tedious process by hand. I'm going to show you on the calculator how it simplifies it quite a bit. Now it's asking us to apply the rational zero theorem. So let's talk about that. The rational zero theorem is where we're referring to finding the zeros. And what that means is I set this equal to 0. And then what that means algebraically is I'm finding what x values cause this to be true. That when I plug in like x equals 5, it causes it to equal 0. Or if I plug in x equals negative 2, it causes it to equal 0. Now graphically, that's where it crosses the x-axis, where y is equal to 0. Okay, now our rational zero theorem. Now we're going to label this number here at the end as p, and the number at the very beginning is q. This is assuming it's in standard form. Now we're going to write down all the products to give us 3. Well, that's easy. We just got 1 times 3. Now you might say that, well, that's a negative 3. Well, how we handle that is we put a plus or minus in front of each one of these numbers. Because you could have a positive 1 times a negative 3, it gives you negative 3, or you could have a negative 1 times a positive 3. Both of those give you negative 3. Now our q, we list down all products give us 4. We got 1 times 4. Same idea. We keep track of the signs just by putting a plus or minus in front of it. That handles all cases. Now the other thing that gives us 4 is 2 times 2. Now I only put down 2 one time. You don't want to repeat numbers. Now all of our possible rational zeros we're going to create by taking each value of p and put it over each value of q. So I got 1 over 1, got 1 over 2, I got 1 over 4. So I took this value of p and put it over each one of these q's. I'll take this 3 and put it over each one of these. So I got 3 over 1, I got 3 over 2, and I got 3 over 4. So we're going to have plus or minus 1, plus or minus 1/2, plus or minus 1/4, plus or minus 3, plus or minus 3/2, and plus or minus 3/4. Typically, it's a good idea when you're working with these problems by hand that you put your integers first. So put the 1. I guess 3 is it. Okay, then I'll put my fractions. So I got 1/2, 1/4, 3/2, and 3/4. This is produced by the rational zero theorem. That's what they're referring to when they say apply the rational zero theorem. Now we're trying to find all the zeros. So what we're going to do is we're going to start taking each one of these numbers and plug them into synthetic division into our original problem. So let's plug 1 in. So I'll plug that in 4, negative 17, 16, negative 3. So I'll add, multiply, add, multiply, add, multiply, add. Let me do that again. Let me start with negative 1. I didn't want to pick an answer the first time. I want to show you what it looks like when you don't get an answer. Okay, now remember this is x to the third. So I'm going to add, multiply, add, multiply, add, multiply, add. Now notice we get a 4 here. What we're looking for is we're looking for a 0. Since we didn't get a 0 here, that means we didn't find an answer. So we go on to our next possible answer. We got plus or minus 1. That was negative 1, so now we're going to try positive 1, which we know is going to work. So that's the first one I did. Now this is still x to the third. So I'll add, multiply, add, multiply, add, multiply, add. Now notice we get a 0. This 0 here means that whatever number's in this box is our first answer. That's our first 0. So x equals 1 is our first 0. That's the factor theorem. Factor theorem says when you're in the middle of this process, if you get 0 as a remainder, that means you found an answer, or you found a 0. Now this was x to the third. This is now down to x squared. This is x, and this is no x. We could continue going through and trying these, but your goal is to get it down to the x squared level. Once you get down to the x squared level, then you can drop out of this process, and you can factor it or use a quadratic formula or something like that. This factors, think. Let's see, minus 12x minus 13x plus 3. This factors as 4x minus 1, x minus 3. 0 factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set 4x minus 1 equal to 0, and x minus 3 equal to 0. So that gives us 4x equals 1, or x is equal 1/4. And this, if I take negative 3 over, gives us a positive 3. Now, fundamental theorem of algebra says your largest power tells you how many answers you're going to have. Since we had x to the third, that means we're going to have 3 answers. And notice we have 3 answers circled here. So those are our 3 answers. Now that's doing it by hand. And you may have to find irrational zeros using that theorem. So that's why I show it by hand instead of just referring to it as a video. Now if you need more examples of that, I do have, I think, one pretty good video on showing a more intense one by hand. But you would continue the process if you didn't get 0 as a remainder. You keep trying those until you found a 0 for your remainder. Okay. Now we're still on this part right here. Still working on the apply a fundamental theorem of algebra. I'm not going to show Descartes' rules of signs or upper and lower bounds. You can go and look at that. Just don't have time. So finding zeros using the T83 84. Step 1. Put polynomial on y1, 0 on y2. Step 2. We're going to do a second trace. We're going to choose intersect. We're going to enter on first curve. We're going to enter on second curve. And then we're going to input an x value close to your answer and press enter. Now if we have decimals, then we're going to do a second mode to X out. That wasn't the video. I'm repeating itself. That was me. And then we're going to do a math, enter, enter. And then step 4, if more answers, go back to step 2. Note, we do not want decimal answers in the final solution. We'll talk more about that. Basically means if you have decimals, you want to change them to fraction. Okay, let's go back to this first example here. And I want to find all the zeros. Okay, so I'm going to go to my y equals. And put my polynomial in y1. Remember, if you have on the newer TI-84s, after you do your carried 3, you have to do your right arrow get out of exponent mode. Minus 3x squared minus 18x plus 40. And then you want down arrow and put 0 on y2. This process does not work if you don't put a 0 on y2. So you have to have that there. Then I'm gonna that was step 1. Put polynomial y1, 0 on y2. I'm at step 2 now. So I'm just going through these steps. So I'm doing second trace. Here's trace. I'm choosing intersect, so I can simply press the 5, the number in front of it. Now remember, our answers are where it crosses the x-axis. Looks like it crosses at -4, 2, and 3, 4, 5. So let's find this -4 one first. Now notice the prompt is asking me in the lower left-hand corner, first curve question mark. So I just do an enter on that. Then it's asking us for the second curve. And I said we just do an enter on that. And then I say input an x value close to your answer and press enter. Looks like -4, so let's put a -5. Negative is the one on the very bottom row, 5, and then press enter. It'll come back and it'll find the answer it's closest to. So it comes back and tells us our first answer is -4. Well, now we're at step 4. If more answers go back to step 2, what do I mean by more answers? Remember, our answer is where it crosses the x-axis. So I'm back to step 2. Doing second trace, choosing intersect, enter our first curve, enter our second curve. I think my next answer is 2. I could input an x value close to it, or I could actually input what I think the answer is. So let's put 2 in, and then press enter. And it comes back and tells us our second answer is x equals 2. Now it looks like we have another one at 5. So let me do a second trace, intersect, enter, and then I'm going to use my arrow keys. So I'm going to do my right arrow key, moving the flashing cursor over close to the one I'm trying to find. It doesn't have to be right on top of it, just needs to be closer to it. This is useful if you're going on to calculus or trig of some sort. And then I push enter. It comes back and tells us intersection is x equals 5. Now, our largest power is x to the third. We said we're going to have 3 answers, and we found all 3 via the calculator, so we're done. Our answers are -4, 2, and 5. Okay, let's take a look at this one. We've got 4x to the third. Right arrow if you got one of the newer T84s. Minus 17x squared plus 16x minus 3. And we're going to do second trace, choose intersect. Now I can see my graphs coming up here, going up above the x-axis a little bit, come back down. So there's 2 answers right next to each other there. And then there's an answer over here. It's coming up and asks us for first curve, so I do enter on first curve, enter on second curve. Now for our guess, I'm going to put 0 in, and then press enter. Now it comes back and tells us our intersection is x equals 0.25. That's might be a pretty easy one for you to spot what it is equal to, but let me show the steps. If you have decimals, you do second mode, math, enter. So push second mode, that's how you quit out of anything. And then math, enter. And that comes back and tells us our first answer is 1/4. Now do second trace, choose intersect, enter our first curve, enter our second curve, and I think the next one might be 1. So let me put 1 in for my guess, and push enter. And it comes back and tells us, yes, indeed, it is 1. Next one looks like 3 or 4. So we do second trace, choose intersect, enter, 3. It was 3. So we found all 3 of our answers. Largest power tells you how many answers you have from Fundamental Theorem of Algebra, and we found all 3. So we're done with that problem. Now let me show this problem here. So we got x to the fourth plus 5x to the third minus 5x squared minus 15x plus 14 equal to 0. Now we're going to have four answers because our largest power is the fourth power. Well, let's put this in the calculator. So go to my y equals clear, x squared 4, right arrow key if you got newer. What's that? 5x squared. I don't think so. Let me go look it up. 5x to the third. Okay. So plus 5x to the third, so caret 3, minus 5x squared, minus 15x, plus 14. We already have 0 on y2, so that's good. So let's do second trace, choose intersect. And looks like our first answer is negative 5.2. So let's do enter our first curve, enter our second curve, and I'll put in a guess of negative 5. Comes up with negative 5.316625. Well, we know how to handle decimals. We exit out, second mode, and then math, enter. Now it doesn't change to a fraction, so we can't use it. Well, let's find next one. Second trace, choose intersect. Next one looks like negative 2. Remember our answers were across the x-axis. So I'll do enter, and I'll put in negative 2. And it comes back and tells us our first answer is negative 2. We can use that answer. It doesn't have decimals. Now again, if you have decimals and changes a fraction, fantastic. You can use that answer. Next one looks like it comes down a little bit below the x-axis, goes back up. Let's put 0 in for the guess. So second trace, choose intersect, enter, and I'll put 0 in. And we get x equals 1. Well, let's put 2 in for the guess, see if we can find that one on the other side. So second trace, choose intersect, enter, and I'll put 2 in. Comes back and tells us 1.3166248. And let's try to change that to a fraction. Doesn't look promising, but we'll see. Second mode, and then we'll do math, enter. That doesn't change, so we can't use that. Okay, well, we found two answers. Let's start plugging these into synthetic division. So we'll start with negative 2. It doesn't matter which one you start with. So we got 1, 5, negative 15, and 14. Remember, this is your x to the fourth, this is your x to the third, x squared, x, and no x. So we'll add. 1 plus nothing's 1. Multiply. You always multiply by a number in the box, but number we put down here. Negative 2 times 1 is negative 2. Add. 5 minus 2 is 3. Multiply. You always multiply by a number in the box, but number we put down here. Negative 2 times 3 is negative 6. Add. Negative 5, negative 6 is negative 11. Multiply. You always multiply by a number in a box, but number you put down here. Negative 2 times negative 11 is 22. Add. Negative 15 plus 22 is 7. Multiply. You always multiply by a number in a box, but number you put down here. Negative 2 times 7 is negative 14. And add. 14 minus 14 is 0. Now this is the factor theorem says if you get 0 as a remainder in this process, that means you found an answer. So this number in the box is our first answer, x equals negative 2. Now that's no big surprise. The calculator told us as an answer, so you have to get a 0 as a remainder. This was x to the fourth. We're now down to x to the third. And on this line we just found, we want to plug in our second answer. So I'll add. And I'll pick up the speed a little bit on this multiplying and adding. Add, multiply, add, multiply, add, multiply, add. Now we get another 0, which means the number in this box is our second answer. So we got x is equal to 1. this was x to the third, this is now down to x squared. And this will be x, and this will be no x. Each answer you plug in and you find the remainder of 0, that takes it down one more power. Now your eventual goal is to get down to x squared, which we do. Have that in this problem. At that point you can factor it, you can use quadratic formula or a square root property. In this case I'm going to use the quadratic formula because this won't factor, and the square root property isn't appropriate because we've got the middle term here. So identify our a, b, and c. A is whatever number is in front of our x squared, which is 1. B is whatever number is in front of our x, which is 4. And C is our number at the end, which is -7. Now we got x is equal to negative b plus or minus square root b squared minus 4ac all over 2a. So we'll plug in what we found. So we got -4 plus or minus 4 squared minus 4 times a, which is 1, times c, which is -7, all over 2a. So we got -4 plus or minus 4 squared is 16. -4 times 1 is -4 times the -7 gives us positive 28 over 2. And that gives us -4 plus or minus square root of 44 over 2. Now we can simplify that radical. Square root of 44 is 2 times 11. Remember the square root, we're looking for a pair of somethings. Here's a pair of 2's, so they're going to come out in front as a single 2. So we've got -4 plus or minus 2 squared 11 over, where'd that negative come from? That should be a positive 2. Now if you can divide, this is a 3-number rule, you can divide this number, and this number by the same number, do so, and they're all divisible by 2. -4 divided by 2 is -2, plus or minus 2 divided by 2 is 1, and 2 divided by 2 is 1, which gives us -2 plus or minus square root 11. Now we found 2 answers via the calculator, and then we had to plug it in synthetic division, do the quadratic formula to get our other 2 answers. That plus or minus accounts for 2 answers. We got -2 plus square root 11 and -2 minus square root 11. Those are 4 answers. Could be at this point you have to use square root property, and there's a lot of examples in the YouTube video I put out there, so I'm not going to go into any more depth on that. Okay, let's go down to rational functions. Now I'm not going to go into every little piece of this because I just don't have the time. But the video goes in more detail. Okay, rational functions. What a rational function is, of course, is a function with a single fraction. So you got a single fraction. Now typically we have variables involved, but it doesn't have to be. F of x equals 1/2 is a rational function. Now to find the domain of a rational function, step 1, we set the denominator equal to 0. Step 2, solve. And step 3, put a slash through the equals. Let me clear that off. If I have f of x is equal to x minus 7 over x squared minus 9x plus 14. Step 1. And instructions are I'm trying to find domain. So step 1, we set the denominator equal to 0. Step 2, we solve that. This factors using the PSD as x minus 2 times x minus 7. Zero factor property, you get 0 on one side, you factor the other side, you set each factor equal to 0. So we'll set x minus 2 equal to 0 and x minus 7 equal to 0, which gives us 2 and 7. Now these are the values we cannot have. So we put a slash to the equals. X cannot equal to 2 and x cannot equal to 7. And that would be our domain. Probably, if Alex asked for this, it'll want it in interval notation though. And how you do that is you go from negative infinity to your smallest number, which is 2, union your smallest number to your largest number, which is 7, union your largest number to positive infinity. And everything has parentheses on it. And that'd be how you write the same thing in interval notation. We have something called an asymptote. This is an invisible line that your graph will skim at some point. In some cases, it may not. Your graph may never cross an asymptote. In some cases, it may cross it at certain points, but will skim it at another point. We have a vertical asymptote. And how you find a vertical asymptote is you factor the top and factor the bottom. So factor the numerator and denominator. Step 2, you cancel if possible. Step 3, set the denominator equal to 0 and solve. Let me look at this example we just talked about. F of x is equal to x minus 7 over x squared minus 9x plus 14. While we didn't worry about it for the purposes of finding the domain, you have to worry about it for the vertical asymptote. Step 1, you factor the top, factor the bottom. So that's x minus 7 over x minus 2, x minus 7. Step 2 is you cancel. Well, notice how the x minus 7's cancel, because they're exactly the same. And we got 1 over x minus 2. Step 3, set your denominator equal to 0 and solve. So we got x minus 2 equal to 0, or x equal to 2. Now what that means is we got a vertical asymptote at x equals 2. Now if I were to graph this, and the trick to graphing these, then this is the only one I'm going to show graphing this, but the trick to it is to put parentheses around the top, parentheses around the bottom. Other than that, you just enter it exactly as you see it. So press my y equals clear, beginning parentheses, x minus 7, closing parentheses, divided by, beginning parentheses, x squared minus 9x plus 14, closing parentheses, and then graph. Now notice, you can't see it, there's an invisible line here, but you can see that my graph's skimming that line. It's going to come real close to it, but never touch it, never cross it. It'll keep going up forever, skimming it. And in the case of the bottom part, it'll keep going down forever, skimming it, but never touching or crossing it. Now, this one you can look at and say, well, is there a horizontal asymptote at y is equal to 0? And there is. We'll talk more about that here in a minute. Because you can see it looks like it's skimming the x-axis, which is y is equal to 0. That's the concept of an asymptote. Now, your T83s, if you have one of those, we'll put an extra vertical line on there where the vertical asymptote is. It's a flaw with a calculator. That's not supposed to be there. It's not part of the graph. It helps you to graph it, but isn't part of it. Okay, let me clear those off. Actually, I could use this one again, so let me leave that on there. I'll use it for my horizontal asymptote too. Okay, horizontal asymptote. We have three cases of this. Case 1, the degree of the top is larger. That means there is no horizontal asymptote. We have case 2, and I guess I better start a new page here. We have case 2. The degree of the bottom is larger. Our horizontal asymptote is y is equal to 0. And we have case 3. The degrees are the same. Degree of the top, the numerator, is the same as the degree of the bottom, the denominator. And I'm going to show this by an example. F of x is equal to, let's say we got 3x to the third, or the fourth, minus 7x plus 2 over 8 minus 5x to the fourth. The horizontal asymptote is equal to 3 over negative 5. Okay, now the degree of the top is 4, degree of the bottom is 4, so degrees are the same. So we're going to take the numbers, the coefficients, off the x to the largest power. So the 3 up here, put 3 here, and the negative 5 here, put negative 5 here. Those are actually the leading coefficients. But when I start putting too much math lingo in here, math lingo in here, then it kind of gets confusing. It's a very simple idea. You just take the numbers off the front of the x to the largest power on top and bottom. That's if the degrees are the same. Okay, so for this example I've been looking at here, we got degree of the top is 1, degree of the bottom is 2. So the degree of the bottom is larger. That means that for a horizontal asymptote, degree of the bottom is larger, a horizontal asymptote is always y is equal to 0. And that'd be our answer. Let me clear that off. And then let's talk about the slant asymptote. And I'm running out of time. Note, in order to have a slant asymptote, the degree of the top must be exactly 1 larger than the bottom. What you do to find a slant asymptote then, sometimes called oblique asymptote in books, use long division and drop the remainder. Now let me show an example real fast on that. F of x equal to x squared minus 5x plus 2, over x minus 1. Well, the degree of the top is 2, degree of the bottom is 1, so it does have a slant asymptote. I do my long division. Take a look at the first term of each side, what goes up on top. You ask yourself what times x gives you x squared, and that's x. Whatever you put up on top, you multiply by what's out in front, and that gives us x squared minus 1x. Subtract that line. X squared minus x squared drops away. Negative 5x plus 1x is negative 4x. And then I'll bring down the plus 2. Again, look at the first term of each side, what goes up on top. You ask yourself what times x gives you negative 4x, and that's negative 4. Now whatever we put up on top, we multiply by what's out in front. Negative 4 times x is negative 4x. Negative 4 times negative 1 is a positive 4. We're going to subtract that line, which means flip signs. That's positive, this is negative. Negative 4x plus 4x drops away. 2 minus 4 is negative 2. Use long division, drop the remainder. When your degree of whatever you have here becomes less than what you're dividing by, this is your remainder. So we want to drop that off. And our slant asymptote is whatever's up here. So our slant asymptote will be y equals whatever you see, which is x minus 4. Okay, that's pretty much what I wanted to show with rational functions. Now I'm just going to give you the steps for polynomial rational inequalities and variation. You can watch the videos on those. Okay, Polynomial Inequalities. Step 1. Get everything on the left side, 0 on the right side. When I say everything, I'm talking about terms. Step 2. Set the left side equal to 0 and solve. And these are referred to as our critical values. Step 3. Using the x-axis, the critical values, and the graph. Then figure out your answer. If you got a greater than or equal to, your answer is above the x-axis. We're talking about where the graph is above it. If you have a less than or equal to, then your answer is below the x-axis. If you got a less than or greater than, then you want to use parentheses. If you have a less than or equal to or greater than equal to, then you want to use brackets. Now, rational inequalities. Step 1. Get everything on the left side, numbers on the right side, or numbers 0 on the right side. Let's see if I wrote that right up here. 0 on the right side. Okay. Step 2, get a single fraction on the left side. That's what rational inequality means single fraction. Step 3, factor the top, factor the bottom, set each factor equal to 0, and solve. And these are critical values. Step 4, using the x-axis, the critical values, and the graph, then figure out your answer. If you got a greater than or equal to, your answer is above the x-axis. If you got less than or equal to, then your answer is below the x-axis. If you got less than or greater than, it's going to be parentheses. If you got less than or equal to or greater than equal to, it's going to be brackets. I'm going to note here, any answer, or any critical value, I should say, any critical value that comes from the denominator always has a parentheses on it, no matter what. Okay, now variation. Step 1 is we want to determine our type. You could have a direct variation, which is y is equal to kx. You could have an inverse variation, which is y is equal to k over x. You can have a joint variation, which is y is equal to kxz. Or you could have a combo, which is a mix of the above. Step 2, pick variables that make sense. Step 3, look for your one example. Use it to find k, then plug k into the formula from step 2. Then step 4, find what they really want. Okay, and that's how you solve variation problems. I'm going to go ahead and stop the video there, and then I'll answer any questions you have.